let us look at the questions. A uniform solid circular cone of vertical height 4r and radius 2r is attached to a uniform solid cylinder of height 3r and radius kr, where k is a constant less than 2. From here we can see that the triangle up here is actually a circular cone in 3D, whereas the rectangle at the bottom is actually a cylinder. So now the base of the cone is joined to one of the circular faces of the cylinder so that the axis of symmetry of the two solids coincide. So you can see here, this is where the two solids coincide. The cone and the cylinder are made of the same material. So when you see same material, that means they have the same density. Now A. Show that the distance of the center of mass of the combined solid from the vertex of the cone is equal to these fractions. So since they said from the vertex of the cone, what am I going to do is I am going to put the vertex of the cone as the origin. So I will just label it as coordinates 0, 0. Now, in order to do this question, that means in order to find the center of mass, we have to work out the center of mass for individual solids here. So let us look at the cone itself. For the cone itself, you can look at the formula booklet MF19 and you will find that it is given that the center of mass of the cone is equal to 3/4 of the height from the vertex, 3/4. So because of this, if, as you can see here, the height is 4r, 3/4 of the height is hence 3/4 of the height is hence equal to 3r. So let's say I assume the coordinates to be here and I call it, let's say, G2. So the coordinates of G2 will take the value of 0, 3/4 times 4r. So which is G2, 0, 3r. So this is the center of mass for the cone itself. So where the 3r is the distance from the vertex to this particular point. So the distance is 3r. Okay, so now let's look at the cylinder down here. So since this shape is geometry, we can easily determine the center of mass for this cylinder. Let's say I name it as G1 as half of the height of the cylinder. So as you can see here, it is given that the height is 3r and half of it is 3/2r. So we want to count the distance from the vertex here. So it takes 4r from here to here, and it takes another 3/2r from here to here. So let us write down the situation in coordinates form. So the x coordinates remain as 0, and then 4r plus 3/2r for the y, and after simplifying you will get 0, 11/2r. Okay, so once we have determined the center of mass for each individual solid, now we can make use of the formula. So let's look at the formula here first. Our formula to find the center of mass for solid made of the same material will be this formula. So I write the formula here, V1 plus V2, where we add up the volumes. Let's say I call the cone to take V2, and let's say for the cylinder it takes V1. Okay, so come back to the formula again, V1 plus V2 multiply with Y bar, the vertical distance from the origin, equal to V1 Y1 plus V2 Y2. So this is the formula to find out the center of mass. And from here, before we start using that formula, it is good to find out the volume of each of the geometry solid here. We start with V1. As we know, V1 is a cylinder. So the formula is pi r square height. So pi, the radius is kr, square, multiply with the height 3r, simplify it, we get 3k square pi r cube. Volume 2, this is the volume of the cone. The formula is 1 over 3 pi r square multiply with height. 1 over 3 pi, the radius is 2r, the height is 4r. So we have this. Simplifying this, we will get 16 over 3 pi r cube. So once you get the V1 and V2, now we can just proceed by using the formula. So I start with V1, 3k square pi r cube, plus V2, 16 over 3 pi r cube, multiply with Y bar, equal to V1, 3k square pi r cube, multiply with Y1. So if you're wondering what is the Y1, Y1 is actually the Y coordinates of the center of mass of the cylinder, which is this one. As you can see the pointer over there, 11 over 2r. So this is the Y1. Okay, so let us label this as Y1, and this is going to be the Y2. Okay, now let's continue with our formula. By the way, I'm using this formula at this moment, so let's continue. We already have V1. Now we have to substitute in Y1. 11 over 2r plus V2. V2 is going to be 16 over 3 pi r cube, multiply with Y2, which is equal to 3r. So let's simplify the equations by cancel off r cube from both sides of the equation. Cancel off r cubed. So let's say I cut it by using green color, r cube, r cube, r cube, and r cube. So after doing so, we also realize that we can also cancel off the 3 on the last term here. I cancel it with yellow color, 3 at the bottom and 3 over there. So I can just cancel off. Now we simplify the equation. So Y bar is hence equal to 33/2 k square r plus 16r over 3k square plus 16/3. So after you get this y bar, it is good to simplify it in this particular way. We multiply with 6 up and down, and hence you will get 99k square plus 96, factorize the r, over 18k square plus 32. And this is the answer for part A. Now let us move on to part B. Let's look at the questions. The point C is on the circumference of the base of the cone. So that means if you can see the cone again, so let me scroll up. So what happened here is point C is somewhere on the circumference of the cone. Somewhere on the circumference is a point. It doesn't matter, it can just be any point on the circumference. So let's look at the question again. When the second sentence here. When the combined solid is freely suspended from C and hanging in equilibrium, the diameter through C makes an angle alpha with the downward vertical, where tangent alpha is equal to 1/8. So to imagine on these situations, it is good to draw out. Let's look at the drawing here. So I draw the ceiling, and this is where we hang the composite solid at point C. So this is point C. The triangle is the cone. And the rectangle over there is the cylinder. Okay, so the solid geometry is in equilibrium, and hence the vertical line will always pass through the center of mass of the whole composite solid. So the center of mass that we found just now in part A, let's say I name it G, and based on the information given here, we have angle alpha. So angle alpha is counted from the downwards vertical. So let's say this is the downward vertical, and angle alpha should be somewhere here, downward vertical to this particular part, so to the diameter actually, as you can see here. Okay, so angle alpha from the diameter, this is the diameter, imagine it's a circular circumference, so this is the diameter, and the vertical downwards makes an angle of alpha. So I will just label it in, let's say, blue color. This particular part is alpha. Okay, is alpha. And let's say I add one extra line here. Okay, and then we know that this is going to be a right angle triangle, and let's say I name or I label this point as point D. So as you can see here, I'm going to consider right angle triangle CDG. So this right angle triangle is going to be considered afterwards. And now let's look at the working. We will use together with the information given, which is tangent alpha equal to 1 over 8. So we know that tangent alpha is equal to, based on the right angle triangle CDG just now, tangent alpha is equal to the opposite DG divided by the adjacent, which is DC. Okay, opposite over adjacent. Now tangent alpha is 1 over 8. I replace it on the left, and DG is actually the distance from here to here. And we have to know that from part A, this value, I mean the answer that we found just now, is actually the total distance. Okay, let me show the original diagram up here. Is actually the total distance from the vertex all the way to the center of mass of the composite solid. So if I'm going to put it in blue color, it looks like this. So all the way to somewhere here, let's say. Okay, so this is the center of mass G. The total distance is 99k squared plus 96 bracket R over 18k squared plus 32. So it represents this particular distance. So now our DG is just part of it. So we have to minus 4R away. So our DG is just here to here. Okay, let's go back to the question just now. Okay, so DG is hence equal to the answer from part A, 99k squared plus 96 R over 18k squared plus 32. So minus 4R, like what I explained just now. We don't want the height of the cone. Okay, so that's why we minus 4R away. We just want DG. Okay, now let's continue. The whole thing divided by DC. DC is actually the radius of the cone, so which takes value 2R. And what to do now is just some algebra stuff. So we have to keep simplifying the equations. Okay, so imagine that I multiply the 2R with the 1 over 8. So I will get R over 4. R over 4. And now imagine also that I'm going to bring the minus 4R to the left. So I will get plus 4R. And on the right, these big fractions remain. So let me write down first. 99k squared plus 96 bracket R over 18k squared plus 32. Okay, so now let's keep doing this. I'm going to cross multiply the denominator to the other side again. So at the meantime, I add up this to be 17 over 4R. So let me write down 17 over 4R multiply with 18k squared plus 32 equal to 99k squared plus 96 bracket R. So I can cut the R away from both sides of the equation, as you can see in blue color. And I just continue from here. 306k squared plus 544 equal to 396k squared plus 384. 99 k square equal to 160 k equal to 4/3. That's all for these questions. Thank you.